For your lab report, I'm going to go ahead and record this. I'll post it as well. For your lab report, you can write it by hand. I will be looking for a page that's going to have, time in seconds, 20, I don't know what it was, whatever it is, and etc. And then you had, I believe the other part of the table was temperature, is that right? Temperature degrees Celsius. Whatever the temperature was, I don't know what it was, whatever it was, right? And then you had some observations, right? All right. And then you did that for H2O2 plus yeast. Then you did the same experiment with H2O2 warm plus yeast. Is that correct? And I'm not going to redraw the chart, but you'd have a chart here as well. Okay? Correct? And then you had H2O2 plus acid. And another chart. Could someone close the door because that noise is going to... So you should have a single graph, one graph, where you have temperature here, or time here. Time is on the x-axis, because time is something in seconds that we call, time is always an example of independent. It's an independent variable. And this is an answer for one of the questions for your lab report. Independent variable. Time is always an independent variable. And it is in this case measured in seconds, but it's independent variable equals time. The independent variable always goes on the x-axis. Then on the y-axis is the dependent variable. And it's just a simple question you ask. And I'm putting an abbreviation. In this case, it's temperature. It goes on the y-axis. And you have to ask yourself, when you're doing this, it's a real simple question that people, for some reason, find it real difficult to understand. But the question is this: which one depends on the other? And ask yourself, if I change the temperature, will it change the time? So time is never dependent on anything else. Time goes on no matter what we do. So it's always the independent variable. But when you have two other variables you're graphing, it can be sometimes difficult. So ask yourself, when I change one, when one changes, what happens? Is it depend on the other? Or does it change the other? All right. Then the dependent variable is going to come over here, so that'll be temperature. And you're going to start at room temperature probably. Starting at 0 is kind of useless because nobody started at frozen. There was nothing frozen around here. You're probably starting at something. You can start, I would start your 0 probably here at 10 degrees. You can start your axes wherever you want. You can start it at 0 if it's easier for you. It doesn't matter. If you know how to use Excel, you can put the data into Excel. I gave you an Excel spreadsheet with the tables already made. Excel is actually really easy to use if you know what you're doing. I wouldn't bother trying to learn it right now, but I think it's something that's very valuable. Whether you're going to go into science, into the sciences, or into any STEM field, or even in business. My wife is a business major. She's a supply chain management individual. She runs supply chains for businesses, and she uses Excel as one of the mandatory classes you have to pass. You have to take statistics, Excel. Man, they're used everywhere. You just can't get away with it. Can't get away from it. Even if you're a history major, you're going to use Excel in some way. So temperature in degrees Celsius. Always put units. All right, always put units. So I'll be looking for that. Did you put units? Did you put the time? on the x-axis? Did you put the temperature on the y? And then start plotting your points. I don't know what they're going to look like, but I gave you one control. I gave you the control group. The control group was no yeast, no temperature change, no yeast. Actually, there should have been one for each. There should have been no temperature change. It should have been one H2O2. I just didn't want to run out of hydrogen peroxide. So H2O2, no yeast. I said there should be one with H2O2 that was warmed, but no yeast. And there should have been H2O2 that was plus acid, but no yeast. That's what should have happened. Those were your, I think I made those group A in the write-up, right? But I didn't want to waste time and also use up money for hydrogen peroxide, so I said, I'll give you the answers for these control groups. And just know that the control groups don't change. They're at room temperature and they don't change. Or in the case of acid, of the warmed, it'll start cooling off. So what you would start, let's say room temperature was at 20, it wasn't, but let's say it's 20. Then your group A would look like something like this. Maybe a little bit variation, but not much. All right, so you'd have a line for group A. Group A, experiment 1. Would look like that. And then in the second experiment, which is you warmed it up, you probably warmed it up to 50 degrees, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Let's say you warmed up to 120. Then what you'd expect to see there is the warmed up version should have dots like this, and then it should start to cool off, right? Because as you're measuring it over a few seconds, it might cool off a little bit, but not much. And so you'd expect when you draw the line here to look something like this. Oh, well, you have to do all the seconds, so do something like this. So that's A, group A. Again, the control group, you didn't add any yeast. Experiment with heated H2O2. Then you had a third experiment, which is acid and the acid and H2O2. So that really was probably about the same as the first one. And acid H2O2 really should look something like that. So pretty much the same as the first, because there shouldn't be any changes to the control group if our theory is correct, and it is. Since I know the answer because I've done it, I'm going to tell you it is. And that's experiment with acid, and I think that was it. This was 3, and I think this was 2. Right? Those are your control groups, groups A, right? Now, if you did what I expected to see, and you don't have to see, I don't have to see these lines, right? They could be different. I'm okay with them looking different than what I'm drawing. I'm just telling you, this is what I would expect. If they look different, that's fine. You just have to explain why. So it's fine if they look different. So don't try to make it look like this, because I'll know you cheated. I mean, it's going to be obvious. The data is not going to match up, and there'll be someone else in your group that won't have done it, and it'll be a mess. Yeah.
On the syllabus for that assignment, it says use Excel or Google Sheets. What is that?
That you can use Excel or Google Sheets. Those are programs that let you put the numbers into the cells and then graph it. It'll graph it for you. If you guys want, after school, I can show you, not today because we have a meeting today, but after school I can show you how to do it. It's real easy. You would just put the numbers in, highlight them, say graph it, and literally graphs them all. Just like that. And then just print. So it's, I mean, there's some tweaking you have to do, but you can make it work a lot easier. But then you would graph it like this, and so those are the 3 control groups. And if you did a different green for let's say we use it. Oh, you know what? Let's just use a completely different color. So let's say for experiment 1, B group, right? Your experimental group for experiment 1. Your experimental groups are these. These are your experimental groups, right? The ones you added yeast, because your question is with Catalase, right? Experimental group. All right, so those are all 3 of these with the yeast. Let's see, with yeast. Does that make sense? So your experimental groups, I'm pretty much giving you all the answers, so if you're paying attention, you should be able to write it up pretty straightforwardly. So experimental 1, H2O2 with yeast, it should have started here, and as time went on, the heat should have gone up, and it kept going up. And then at some point, depending how long you ran the experiment, you might have seen it come down, but I don't think the amount of time you measured it, I don't think you saw the temperature come down. So it should be something like that. And then maybe not that high, I'm just exaggerating it so you see the event. So again, that's the experimental group with just hydrogen peroxide and yeast, plus yeast. No increase in temperature, no acid. What we should have seen in experiment 2 with the increased temperature, but no acid. Increased temperature but with yeast is if it worked out well, it should have followed the same pattern. Maybe it got a little warmer at first and then it started decreasing. So there was still that decrease happening long term. So it was not increasing temperature, and maybe something you might have noticed is, and we annotate graphs. It's called annotating them. A lot less O2 than room temperature. And maybe this one, a lot of bubbles. All right. And then what should have happened with this one, like that was the one with the bubbles, right? The H2O2 at room temperature with yeast. But when you added acid, maybe you saw this happening. Maybe it went up a little bit, but probably not. And what you got was something like this. Experiment B with acid and yeast. And there's no bubbles, or a lot less. So the 3 experimental groups should demonstrate, that's experimental B, warm H2O2 with yeast. And notice I grabbed all the lines on the same graph. And I just use different colors, but if you don't have different colors, you can use different shaped dots. You use dots or asterisks or triangles. And what this shows you, if you interpret the graph, first of all, the control groups did not change in temperature, except the warm one probably started cooling off because everything cools off if you let it sit for long enough, right? So it didn't really do much. There was no increase in temperature in any of the control groups, and that's what we expect. There were no bubbles in any of the control groups, or a few bubbles, no actively bubbling substance. In the H2O2 with Catalase at room temperature, the bubbles were a lot of bubbles, very frothy, increase in temperature. with the H2O2 that was warmed up, there was either only a few bubbles and probably maybe no bubbles at all, depending on how hot it was. At 120, I'd expect no bubbles at all, and it would be cooling off as time went on. It probably didn't cool off much because it's sitting on the table for only like 120 seconds, so I don't know how much cooler it could get in that time. Then here, with the acid, there should have been, again, a lot less bubbles at room temperature, certainly with the yeast, acid with the yeast, should have stayed about the same. Maybe you had a few bubbles, maybe it got warm a little bit, but not by much. And then quickly, it just flattened out and stayed straight. And why? Because the acid denatured the protein. So again, I'm giving you the explanation for the lab report. The acid and the heat, you had an enzyme that I'm going to go ahead and draw like this. When it looks like that at room temperature and pH equal to 7, it looks like that, and it works. It breaks hydrogen peroxide into oxygen gas and water. But when you increase increase temperature beyond a certain point, it looks like this. Shape change equals what we call denaturing. And that makes sense. It's not natural. Not natural. So where it looked like this originally, now it looks like this. It doesn't work. It does not break down H2O2. So H2O2 does not get to go and change. Where up here, H2O2 changes to water plus oxygen gas. Right, so there's your bubbles. And the increase in temperature is because of the release of the energy from the chemical bonds being formed. So then again, you decrease pH, which makes it more acidic, which is what we did. Decrease pH, and what we get is again a conformational change, a shape change, which equals denaturing. When you denature a protein, it does not work. So H2O2 does not turn into water and oxygen. It won't go. This doesn't happen. So that's what that's what your lab writing should be similar to that, with your own understanding of all these things we just talked about. Is that fair? All right. And it's all related to the stuff we talked about in class, all the stuff that's in the book. In fact, the book shows you a graph of the energy changes during enzymatic changes, how enzymes change chemical reactions. You had sugar iced tea. There should be no reason you're falling asleep. It must really be boring. I know it's hot in here, though. Could you not put your glasses on the stone table with the glass down like that? Do you know what happens to glass when you rub it on stone? You can't guess? It scratches.
They break.
Oh, that's good. Eventually, yeah, but they scratch up. All right, so we're good with this. If you have trouble, once you're doing it, if you have trouble, come and see me. You got till Wednesday. If we need an extension, I could foresee us giving an extension on your first lab report. That seems reasonable. But I need to see some work. I don't want anyone not working on it and then coming and saying, I need more time to do nothing. That doesn't make sense to me. All right, are we good? All right. Can I go on now with the other content? Is that fine? Yes? No? Maybe? Are we good? Yes, no, guys. I know you're tired. I can see it. I know it's hot in the room. I don't really feel it's that hot, but that's, yeah.
Last question, so for the paper, it's just one page?
I can see you doing it in one page. I would say it's probably going to need to be a couple pages because there's a lot of questions to answer. And it depends how neat you are with your writing, but yeah, you can do it in one page. I don't care about the length. I want to see the quality. If you write efficiently and you're not going to just do a lot of explanations, that's okay. I just need to know that you have to explain at the minimum, answer the questions. So if you're not answering the questions, then you're going to get loosened points. That's the only caveat. And then your graph has to show this stuff, right? The stuff I have here. And since I did it for you already, I don't think that should be hard. And if you have data, once you graphed it, if you have a problem with it, you can't explain it, you can come and talk to me. You also have each other, you can talk to each other. Okay? Everybody good? All right.